next session will be until we have like 4 speakers, and I will now just introduce the first 3 because I think they're just going to do it one and then the next one will come and then we will have gifts and everything in the end because it's instead of me running up and down here. So first we will have the interoperability journey for the Netherlands with Sylvia van Laar. So looking forward to the journey of Netherlands. After that, we will go to EHDS Internet Initiatives in Europe with Licínio from SNOMED. And then we have Stefanie Weber with SNOMED SN11 and also a lot of things going on in Germany. And then we move to Innovation Spotlight with Anthony Shek. So with that, I think I will just give the your audience from you, Sylvia. Thank you.
Thank you, Alfhild, and thanks for the invitation to speak here. I will check if it works. Great. And there we are. This afternoon, I will talk about the interoperability in the Netherlands. And as in most of your countries, it has been a bumpy road. But still, I hope it inspires you as well, and maybe take some lessons from it. Some bumps you should not take. And what I will be explaining you first is our Dutch healthcare landscape. It's a bit different than the one in Norway. And the road behind us are milestones we already passed and what we're working on today, and our vision and road ahead we have for the Netherlands. So what I said, I need to explain a little bit about our Dutch healthcare landscape because it's a private healthcare sector. As I've shown here on the right side, there are a lot of healthcare organizations, hospitals, GPs, everything is private, but it's non-profit organizations. We have, of course, university medical centers, hundreds general hospitals, outpatient clinics, and around 9,000 GPs. And all these private caregivers do have have a wide range of EHR, EMR suppliers. So that's quite difficult than in some other countries. And what's also important that we, as I'm from the ministry, I forgot to introduce myself, doesn't matter. I will just give you the talk. Well, what we can do is we make sure the quality of care is good, but we cannot intervene in everything. I will introduce myself for a little bit, so you know why I'm talking today. I'm a policy officer and work on semantic interoperability. So SNOMED is one of my focuses. I also work on clinical information models use, and I work a lot with my lovely colleagues from the organization NICTIS, who are also here. So that's what we do. And of course, you know, Herco is also one of my colleagues. And the last thing I want to tell you about our Dutch landscape is that we do have healthcare insurances. It's mandatory, but it's also private. A lot of private, but we still can do something in our country. And if you look at our landscape and the things that will be changing in the future, these are challenges that will be familiar for you probably, as in rising costs, aging population, and that will also result in shortages of staff, and the administrative burden. And this burden also, rises because patients get more and more different healthcare professionals, and you want to have their data to go with them, so you need to document well. Yeah, that's readable. So these are our challenges, and well, we tried to tackle them already, but if you look behind us, where do we come from? Well, one of the things, even though I was in high school yet, I'm quite proud of is that in 2007, the Netherlands was one of the countries that started SNOMED. It was part of the charter members, and I think that's very, well, happy that it's still here. And a few years later, in 2009, our Ministry of Health started on a law making a national electronic health record, patient record, which was a very good idea in the basis, but 2 years later, the Senate stopped this development with a very hard stop sign and said, no, we don't want this national health record because privacy problems. And after that, the national direction was like, we don't want it anymore. The responsibilities went more and more towards the healthcare providers and organizations. They took responsibility about the health infrastructure. However, 7 years later, 2018, they said, okay, we tried, but please, Ministry of Health, we realized that we actually need your help. So this is a cloudy picture from our office, and of course you want the sun to shine again. So we started working on laws and other topics, and one of the laws that is now in place is a law that looks a lot like the challenges we want to tackle with the EHDS, but it was started in 2019. And the interesting thing and the very nice is that this law, instead of the other one, was passed by both of the houses with unanimous votes. So everyone in the political area realized we actually need some mandates to facilitate electronic exchange of data. And if you look at the use cases, such as a patient summary and medication and long-term care, these kind of overlap with the EHDS use cases, and so there will be a lot of work to make sure they will align. But this is one of the big things we have done and one of the big milestones since 2018. And one other topic that was done in 2018 is the publication of our national vision on interoperability, semantic interoperability. It was a very big report from NICTIS and the other organization. And to sum it up, it's the famous or not so famous Mickey Mouse model, which said for primary use registration, we want SNOMED for the big part. And the IDMP, when it is finished, we want to use it for medication. And LOINC, we want to use it, for example, for lab results. And as a second layer, there's other code systems such as the ICD-10 and ICPC to use. As I said, this is a report from 2018. We're now working on a revision of this report because a lot of things happened since then. But this is the base model we are working towards, making sure these terminologies in light blue actually will be in practice. And the journey today takes us, well, this is a picture from The Hague, which is very relevant. The journey last year took us to implementation strategy, which is the orange journal letter advice that says, please, if you want to implement it, use certain types of steps. Very clearly described, this was an advice which was written with a lot of people from the field. And everyone, there was like a big consultation and everyone agrees, okay, we need to take these steps. We also, our minister wrote a letter and saying, okay, we agree with this, this way forward. And what does it say? It's a what, how, and what do we need? Very simple idea. It's not very simple in practice, but what do we want? We agree on the use of SNOMED and we start actively implementing it in 6 sectors, which is very big. So you have not only, we have like the GPs, secondary care, but also mental health, health for children, and 2 more. And start with diagnosis and treatments. And that's what we are working on at the moment. These 6 sectors are making plans, or they have submitted plans on, okay, this for some it's a big challenge because they're coming from different backgrounds, as in, for example, if you use ICPC, what do we need to do? We are working in a nursing home. Where do we need to go? How do we deal with classifications? A lot of challenges, but they are willing to put in the work. And we are making now plans. We're combining those plans and looking for a roadmap towards the future on which steps to take to make it actually come true, that for all diagnosis and treatment, SNOMED is used. And here comes the exciting part from The Hague, where our parliament is based, is that today we have a debate going on about, how do you say it? Well, health informatics. And it was quite a pity we could not be there, because I also like those things. But we just heard that our minister declared that she wants to make SNOMED mandatory, which is quite big news. And I'm also quite proud of it, and I hope you do too. So steps forward, if we have SNOMED implemented, or what do we want extra? What you also know, there has been a collaboration with the WHO and SNOMED International, and Stefanie will tell you more about it. But what I want to tell you is what our part of the journey was in this, and it was, well, it started with the resolution in 2019, that ICD will be coming and should be implemented in 2027. And that was followed by the joint statement of EU countries, but also Australia, Canada, etc., to make the alignment a priority. And well, this has been a lot of work. How can we make sure this aligns? What I just want to mention is that we try to organize on the 19th of May in the WHA meetings, a side event, which would be organized by our colleagues in Geneva, which would be co-hosted by India and Germany and Brazil. And we want to put this topic on the table there as well. And so this was a lot of stuff already, and now we zoom a little bit out the road ahead. Where can we go further? Because, of course, semantic interoperability is one thing you want to organize, but actually you want to do it because you want to achieve a health information system that works for people. And therefore we developed a national vision on the whole information system, especially because we have all those different vendors and sectors, and they need to start working together. So we have 8 points that are crucial. Data availability, of course, minimal administrative burden, create a network of infrastructures that is needed because our systems are different. And also you work on the data solidarity, so everyone also is be willing to share, make sure, like care for the data as well, because if you make sure the data has good quality, you can be able to share it in a proper way. And the system should not be available only for like hospitals, but it should be available for citizens and healthcare providers through the whole country, through apps, for example, and all the different systems. Also, which is relevant, is of course governance around this. And what I said, it's not only hospitals, it's a wide domain we want to improve. So also the social domain and the public health domain. And as the last one, we want to make sure we create a level playing field for IT vendors to make sure it's an open market for everyone to join and to improve the health. I think I have 2 more slides, yeah. You can also sum it up in 4 pillars and some core principles, but data availability is in both. The first one, you see, it's making sure everyone has the necessary data when needed available. And as you all know, it can be primary use, but secondary use of data can be very, how do you say it? It can be very relevant, a lot of insights. It should be focused on functionality and stimulate innovation. What I said, the open market is very important. To create this data availability, you also need trust and reliability. If you don't trust the data, no one will use it. And it's quite a challenge to make sure everyone can trust the data. How do you do that? And the last one here as well is the governance around it. It's a long way to go. 2035 is far away and also not so far away. So we made 3 parts of it. The stuff we need to do now is establishing interoperability. Looking forward is establish this wide care-based network. And in the end, our big dream is establishing integral care-based network. These 3 stages are very detailed. I will not go further into these. But of course, those goals, well, they're not just saying, they need very specific works, of course. I want to stop here and give my give the stage to the next presenter. But thank you all, and of course, questions are for later.
So, good afternoon, everyone. Let me just make sure. So let's proceed. Let's proceed with the European Health Data Space and the link with SNOMED International. I would like to ask you a favor, and please play along, okay? It's an exercise to open your mind and see what is inside it. Can you please scan the code behind? You also have it in the sides. And while you do that, I will introduce myself. My name is Licínio Kustra Mano, and I promised before the end of the presentation a story about Kustra Mano that will be meaningful for this presentation. And I work at SNOMED International, and my role is to work with the national release centers in trying to implement SNOMED the best way we can. And that's where I met the Norwegian NRC, the Trine, Alfhild, and also Kim. And I start to wonder, oh, are the Norwegian people all like this, with this energy, with this will to make it happen? And then over the last days, I've met more people, Norwegian people, and I think, oh, after all, it's a characteristic of the Norwegian people. So that's really impressive. So this is the privilege to work at SNOMED International, is that we can meet people like you all around the globe. And before I continue, just to mention that in my previous 8 years, I work at the European Commission in the team that designed that was responsible for designing the European Health Data Space regulation and the underlying infrastructures. So I have a question for you. This is open your minds. So what is the first thing that comes to your mind when you hear the EHDS is coming? Please use emojis if you can. Interoperability, finally, good. Oh, that's interesting. That was a number. Sharing patient data across borders, agreements, rock sign. Oh, that's so boring. I like the boring ones. Oh, the rainbow. So it means like it's an ambition we can fear. Oh, I hope I will take a picture of this so make sure that we have the feelings around it. So indeed, the EHDS creates a lot of exciting hopelessness. Finding okay, that's it's that a term in SNOMED CT? Okay. So let's go back and let's do something. Let's read out a little bit. Okay, let's take away our feelings from the topic. Okay, let's try again. If we can go to the next one, what is the first thing that comes to your mind when you hear the EHDS, the European Health Data Space, gives me the right to? Can we go to the cloud and see? It's a bit more tricky. Let's see. What is going on? Okay, share data, access my data, be in charge of my data, manage terminology, big eyes. Okay, I'm not sure we want this. A lot of love there, smiling, okay. Clappings, primary, health, taking my data with me. Share is getting really big there. Access my data, share data. I like the train, I like the, okay, so I think we'll need to make a study to understand the impact. Oh, what? The thing, the hammer there, it's quite interesting. And people, what is that sign? I'm not sure what it is, but okay. I don't know what to think about this, all right? Okay. So let's record also this picture, and let me go back to the presentation and actually share what it is for me based on my experience and the work that I have done in the past. So for me, the EHDS means a strengthened citizens' right to access data. Why I say strengthened? Because in the European Union, there was this thing that was called GDPR, General Data Protection Regulation. And that ensures that all of us around Europe, we have right to access to our data. So our data in a hospital, we say, we would like to have our data. The issue, why it is strengthened? Because at this point onward, it will be in electronic format, so it creates the right, the obligation to be in an electronic format, but most of all, in a common European exchange format. So the data needs to be in a common structure, in the common terminologies all around Europe. That's the strengthening of the right. So the next point is interoperability requirements for electronic health record systems. So I guess you already heard, whenever you go into a hospital, oh, the data is stuck, the data is siloed, so no one can take out the data from that database. So the idea is always, okay, we have structured data, now we need to create requirements that will enable the data, the portability of data, so that data can get out and no one closes the data. And the last one, why do we want to do that? There are several reasons about continuity of care. The patient may need this data along the way. But there is one important angle that it's not minor. For me, and personally, it's connected with the story I will tell in the end, it's one important thing. That is the common process to reuse health data. A common process based on legal requirements that enables anyone in Europe to access to data anywhere in Europe. So this has a potential, and I guess you already see where this is going. So let's go. The walk, what is the path here? So last month, 26th of March, there is this thing that is called entry into force. So this is published in the official journal of the Union. So this is when the clock starts ticking. Starts ticking forward. In 2 years from now, this high-level regulation needs to be specialized in what we call technical specifications. These technical specifications will define the implementable instructions that are legal requirements. And those legal requirements need to be applicable. That's when you break the law, when we don't comply with these requirements in 2029. But they start with first two things, first two categories of data, the patient summary in e-prescriptions. What this means is that the ambition is every one of us, European citizens, will have the right to access to their patient summary and our e-prescriptions in a common format, wherever we are in Europe. And then, for secondary use, it means that the key responsibilities like concepts, a data holder. So I'm a hospital, I have data with me. What does it mean? I need to make this data discoverable. I need to make this data available when the health data access body requests me the data. So the key principles for the secondary use enter into application. So from this moment on, you break the law. So in terms of this means, 4 years. That's why there was a lot of stress in the first slide when we say the EHDS is coming. So in 2031, it adds up. So besides the patient summary and prescription, we also, the same concept, having it in a common format, is extended to images and image reports. It's go also to test results, including laboratory results, as was mentioned before. And then it also have discharge reports. Whenever a patient is discharged from a healthcare facility, there is a discharge report. And this discharge report needs to be in a common format so that it can be understood and relevant for the continuity of care. And of course, in the secondary use, still in 2021, there are additional requirements, additional data categories for reuse. And these are the critical ones, is genetic and clinical trials. And to finalize, there is also interest from third countries. Third countries means countries outside the European Union to be able to tackle into this European health data space. And the provisions is in 10 years from now, you will be able to join. After this is stable, secure, we will be able to open to other countries. So the timeline of 10 years, this is public, this is in the regulation. This is in a nutshell what it is. So if you try to see this now from a layer approach, what we are trying to say is there will be here this, for citizens and health professionals, this layer of standard data standardized across Europe. That data will be unlocked because the electronic health record systems will have requirements for interoperability and logging. Logging means who access to that data and for what. So this will be common to all electronic health record systems in Europe. And then the third layer is the common legal and operational framework that enables access to that data across Europe. So one of the questions that we hear a lot of time when we are speaking, so is this data that is in primary care is the same data of secondary care? There is only one data, is the real world data. So that's where it starts in the primary collection of data. So this is more or less European health data space in terms of what it means, in terms of the basic building blocks. So how does SNOMED come into the picture here? So the first thing, imagine yourself when looking to 50 years of data and you try to understand what does this data mean to me today, right? And when you look back, you say, oh, this was used with the language, the terminology that I cannot understand. It's not even the format, it's the, I cannot understand it. And this morning we heard the expression, a gold mine, right? But I cannot extract the gold because I cannot understand what it says. Oh, it's a gold mine, but it's only in my country because with the terminology that I use in my country. Yeah, but sometimes for certain findings, you need to have critical mass. In your country, in rare diseases, this is very clear. In rare diseases, you cannot establish the finding by looking to the 5 patients you have. You need to look to a broader range of population. So if you what happens, and thanks Gemini for the picture, the data might hold invaluable insights like disease patterns, like treatments, how you treat that patient, population health trends, but without understanding the language, the terminology, you cannot extract value. You speak with any data scientist and it will say, if I don't understand how this was created and what it means, I cannot make correlations between data. So the consequences for the European society and the world are unthinkable. So it's about patient safety, with treating someone without understanding what happened in the past, what happened in another country. Loss of clinical knowledge because something that worked in one country does not work. We don't know how to do it here because we don't understand what they did in the other country. The health professionals, they need to redo exams. They need to try to do again the same things for one single patient to actually understand what this patient has. Reduce cost efficiency. Our health systems in Europe are all struggling with the costs, and the scientific stagnation, you already can see it. If I don't understand this data, how can I make sense out of this? How can I create knowledge on top of the data? And at SNOMED, we believe that terminologies need to be future-proof. And what does that mean, future-proof? So the first thing is that they need to be multi-language and multicultural. So they need to have, in its basis, the terminology need to have a model that allows for that instantiation, different countries, different languages. Then they need to be well-maintained. It's not about, oh, this is great. Oh, when you look to today, this is great. These are not static things. This will evolve, and you need to have an organization that has transparent and efficient processes behind that ensure you, the users of the terminologies, that it will maintain and will evolve. This is something we pay extremely attention at SNOMED International. Then it needs to be interoperable. No one will reign over everything. So the question is how these terminologies link to each other, creating meaningful links and meaningful uses for the health professionals that start collecting data and for the data scientists that analyze. So that's why we work a lot in establishing collaborations with other terminologies. And final, it needs to evolve to follow the clinical knowledge evolution. So it needs to have a very good process of including content and quality improvement on that. So as I mentioned several times, at SNOMED International, these are things that we put at the core of our operations in order to deliver SNOMED CT as one of the best terminologies in the world. So coming up to the end of this story, I believe, and this is I'm changing to I because I will tell you now the story. I believe that our world needs a global future-proof terminology. So Mano, Mr. Mano, my father, passed away with 57 years old. And he passed away after 12 years of an underdiagnosed Cushing disease. So the doctors spent 10 years to try to make sense of volumes and volumes of data that they couldn't understand it was related with Cushing. So when they finally get to the diagnosis that it was Cushing disease, because they were looking to the data of my father, but there was no references around it. So it was too late, the damage was big, and 2 years later, he passed away. Mr. Kustra, my father-in-law, he passed away with 67 from pancreatic disease, pancreatic cancer, let's put it this way. The first 3 years, the chemotherapy worked flawlessly. So it was a case study. So the cancer disappeared almost for completely, and no one understood why, because the chances of surviving pancreatic treatment are very low. So what happened after was, oh, we need to make a surgery on a vein that connects the pancreas to, sorry, I'm not familiar with the body structure that comes after. So the doctors were looking to that and saying, no, it cannot be done, it cannot be done. So we picked up, can we take the information? And we took the information. It was already PDF documents and CD-ROMs with the images, and we picked up on that, and we took it to a translator, to German, that translated the health information to German, and then we sent by email to a doctor in German that had success cases on that. The doctor in Germany said, this can be done. And the doctor came to our country and actually made the surgery. The surgery was a success. However, in 3 years after, the cancer came back, and it was like a matter of 2 months, and he passed away. So from this story, it's not that special, it's my story, but I can guarantee if you count 1, 2, 3, 4, one of each 4 of you has a similar story about this. So my personal problem is, I made this my mission. I don't want my children to pass away because of the same diseases of my parents. So I have Lucas and Eva, and I'm sure Lucas and Eva, you all have Lucas and Eva, your children. And so that's why we need to start considering that our role as terminologists, as citizens, as health professionals, as EHR vendors, as data analysts, is to ensure that health data remains comprehensible and reusable for generations to come, so that our children can have, and perhaps ourselves, can have longer and healthier lives. Thank you very much for your time.
Thank you very much. So I got one of those fancy microphones as well, but I'm not sure I can perform as entertaining as Licínio did and pass the message as personal as he did in the end. So I'm going to talk to you about SNOMED and ICD-11, but I'm coming from a German perspective. So why this is important to us and what we're hoping to have in the future. To kick it off, who am I? My name is Stefanie Weber. I come from BfArM, which is an institution in the realm of the Ministry of Health. We do have as a main task the regulation of pharmaceuticals and drugs and medical devices. But since a couple of years as well, all the code system and registry topics that are handled by the Ministry of Health are under our roof as well. And I have the pleasure to chair this division with all the topics in it. So looking at code systems, I think we're at BfArM are very fortunate that we have a lot of things under our roof. So we have the whole HUFIC classifications. Here's the ICD-11 topic in as well. We do have SNOMED, so we are the National Release Center in the same division, so we can talk to each other on a daily basis. As well, we have a procedure classification, that's this OPS here, and which is really driving our billing. I'm going to talk about this in a minute. But as well, the pharmaceutical terminologies like ATC and the ISO IDMP topics. So we're kind of a code system experimenting with how would this work together. For us, ICD in Germany is crucial. We have been on the ICD journey for quite a while. So we introduced ICD-10 even in the late 1990s in Germany, and we used it for many, many purposes. And so the ICD-11 was very dear to our heart when it came in the revision, and we engaged quite a bit. So we have a HUFIC collaborating center on ICD-11. We spent quite some time on the development, and we are very happy that it's out there now. We have translated the whole ICD-11 already. It's out there with the medical societies getting reviewed and checked for consistency and for real clinical terminology in it. We're doing some transition studies, not enough yet. We need to do some more on this. And we're preparing for crosswalks and so on. Still, we're not really having a path on when we're going to implement it. Why? because we have implemented ICD-10 in so many systems. And as you can see, there's quite a lot of money behind ICD-10 in Germany. So our DRG system, which does all the reimbursement throughout the hospital sector, so this encompasses about 80 billion euros per year, is triggered by the two classifications, the two code systems, ICD, which we modified, German modification, to fit our needs, and by our procedure classification. So ICD-11 would really have to step up to this. We really have to make sure that by switching, we don't screw the whole system. Of course, all people interested in money are asking for this to be implemented. But then there's the electronic health record. And the EHDS, which Licínio just introduced, is really setting the stage for Europe. So here on the right side, you see the electronic health record of Pretty Bodo we heard of in the morning, so the guy who's going for the cruise. And on the other side, here is Europe, but of course it would be any country in Europe that ideally in the future would have the same system. So we are setting this up on the lower part here, you see, and as so many people here apparently are from Germany, can pronounce it in German, it's EPA für alle, so our electronic health record for each citizen. So it's maintained by the insurance companies. You have the right to opt out of this, but most people will have it. It's going to be mandatory for all health insurances to offer it to all patients this year, and we're starting to implement it. This comes with of course, with the regulation, and we're trying to align this electronic health record directly to the regulation so that we're able to bring our data to Europe. So in this electronic health records in Europe, there are already some specifications set. You can see here, for example, this is taking from the patient summary, so a use case that was discussed worldwide quite a bit, so I don't need to go into this. But there are fields where already preferred code systems are listed, and some of them, there are a couple of code systems listed. So as you see here on the button, it lists the ICD-10, it will list the ICD-11 in the future, it lists the SNOMED CT, as well as it lists the ORPHA codes. So it's 3 code systems here. And for us really is the question, how do we bring this together? How do we cater to this? So it's really dear to our heart. And as you have seen on my second slide, no, it was the third one, all these little wheels getting into each other. We at the Bay Farm have to make sure that we deliver something to our users, to our coders, that kind of interacts and is possible to make usable together. So for us, physicians, nurses, all kinds of healthcare personnel are really complaining a lot about documentation and bureaucracy. So we can't go in and tell them, you have to document SNOMED for the electronic health record, ICD-11 or 10 for billing, and then you have to do the ORPHA code for rare disease registries. So how do we make this possible that the bureaucracy and the time you spend for coding and documentation is low? This is really the question that's driving us, and that's why we sat down, because we have the German edition now of SNOMED, only a subset. We have the translated ICD-11, we have ICD-10, we have everything there, and we started a terminology server, and there we said, how can we bring this together? So we came up with a strategy, and it's a position paper yet. We're not as far as Sylvia pointed out. We don't have an official mandate to move this forward, but we're bringing it to discussion. On the last slide, I have a barcode. You can scan it and then go to this webpage. It's unfortunately only in German, so I'm going to explain a little bit. This is our status quo in Germany. It's not as fancy as Mickey Mouse model, so we're going, like we're German, we use blocks and we're sorting everything. So on the left side, you see we have a lot of individual single code systems, so little lists like the reason for encounter or the reason for dismission from a hospital. It's just a list of 1, 2, 3, 4, 5, and it's something that people came up with who are doing this on a day-to-day basis. Then we have a national code system, and here the procedure code system is, of course, the main one, so that we're thinking of. So it's a procedure system of 34,000 codes, very detailed. It has all kinds of numbers in it, like putting 3 stent on the left side of your aorta, abdominal, whatever. So all kinds of combinations in there. These are systems that are used in many use cases, but they're still very local. And then on the third column, we have the international code systems. Here we would definitely see the ICD, OFA codes, so code systems or the LOINC code systems that are implemented wide. This green layer here is what the law gives us for the electronic health record. So it says that we should provide SNOMED and LOINC for the electronic health record and to provide it through the terminology server. So what can we do? So we sat down with our team, we discussed, and we said our vision for the future would be to go in a medium term to try to merge those little single-use code systems as value set in this layer of base coding systems. And we explicitly did not specify exactly what those base coding systems are because we need to develop this on the way. Of course, SNOMED will be part of this because it's such a wide terminology. LOINC will be part of this, and we're very happy about this common ontology between SNOMED and LOINC. And we hope that more can go in there. Pharmaceutical code systems might be necessary there to add on. In this stage as well, we would develop some more mapping and make the mappings more precise on the international classifications. For example, for our German modification, we would need some more refined mapping that is available internationally. And that is our long-term vision. So in the long-term vision, those base code systems would cover almost everything you need to cover in a clinical documentation. And from that, we derive by mapping or by whatever mechanism the national aggregation level, which is really needed for the billing and for the documentation. So if you want to group, if you want to reimburse, if you want to make statistics, you need this classification level. But if you want to document, you don't need it at the time of documentation. So that is kind of where we're aiming at and what we're putting up for national discussion right now. So we had it at a couple of meetings in Germany. And that's really now where our hope for the future lies. And I'm coming back to the title original. So SNOMED and ICD-11. For us, it's not a question this or that. It's a question, how can we use it together? Because we need both of those systems. We need this aggregation level to make sure that we can cater our needs of billing, of statistics, of these long-term trends that we have in epidemiological research. But we do need as well SNOMED for our electronic health record and for the big data collection that we're aiming to have with it. For the secondary use of data, we can't group and aggregate data only because then, and the fancy talk afterwards on AI, we'll see what you can do with lots of detail. So we can't do this only on a classification level. So we are very excited that WHO and SNOMED are talking about how this could be made possible on a level that both systems can be used together. And this on the right side here is what we would be hoping for, that the systems are not really seen as separate systems, but they're seen as a joint system, like it's called unified healthcare terminology in this slide, and that whatever use case you come from, you can derive it in a way that caters to your use case. So if you're coming from a billing use case or a statistical use case, you kind of can look at the ICD view, so classification view. If you're coming from more of a research or clinical documentation point, you're more looking at the SNOMED view, and on top you see those linearizations. That's a word that ICD uses a lot. That is, if you have a specific use case, you can take a small subset of ICD to use it. It would be value sets in the SNOMED language. So it's kind of something like that. Why do we want to hope for this as well for us in Germany? We have to translate. We have to translate two systems if we keep it separate. We have to maintain. We have to give change proposals. So whatever we do, it duplicates our work as well. So our hope is not only for the users, but as well for us internally at BfArM, for all these little wheels you saw on the first slide, to lower our burden, to lower the amount of resources we need to put into this, and really to move healthcare forward with such an approach. So that's why we're very happy, and we're hoping that with the side event that Sylvia announced, there would be some more understanding as well from other countries on this topic, and some more engagement, because this is not something that the two organizations can do alone. They need the support of the user groups and of the community. So why coding system? We hear a lot, coding systems are not necessary. We can just use big data and AI and we will know everything. We don't think so, especially for the use case of billing. This is going to be too tricky to do it with AI now. Maybe 20 years from now, it's a bit different, but not now. And we think the harmonization of code systems is really essential. It's not manageable if you use them all in one environment, but they're so separate. So you really need to bring them together and make them interoperable on the code system level as well, not only on the data level. So our national strategy really must consider the whole data flow from the point of data capture, where we say the code once, use multiple times strategy, until the end in the research environment where we make research on big data. This needs to be interoperable, and therefore we need to have a strategy for this. And the joint implementation of the two systems can really take the strengths of both systems. Both systems are coming from a different approach and have very good qualities that we need for a health system. So we hope that we do not have to choose at some time, but rather bring them together in our environment. And that's my message for today. And here's, if you want to scan that, it's not going to be interactive. There's no smileys coming up, but you can see this paper. It's unfortunately only in German, but I think after the explanation, I hope you get the message. Thank you very much.
So fantastic. So very good. And thank you very much for the three of you to introduce yourself. And then hold on to the questions that you have to the three former speakers, because I think you've done a marvelous job with the presentations. So hold on to that until the last minute, because I'm going to have a little wrap up before we leave before today. So now I would like to also introduce our next speaker, who would be Anthony. So Anthony Shek. He holds a PhD of clinical neuroscience, and he creates and deploys cutting-edge natural language processing, NLP, pipelines into major hospitals across London. With expertise in large language models, Anthony integrates them into electronic health records and systems and clinical workflows. He develops tools that are enabled to clinical to uncover trends from millions of records, driving service improvements and insights into disease progression. So we are looking very forward to hear you, Anthony. Thank you.
Brilliant, thanks. Thanks for that kind introduction. And actually, a lot of the topics that I'll be covering today have already been mentioned. I think healthcare is a universal problem that has no barriers. It's something that we all face, despite which country or language that we live in or speak. And so I'm here today to talk a little bit about AI. Yeah, about AI and healthcare and how they fit together, and SNOMED as well. Great, so just what I'll cover today is just a bit of an introduction to healthcare data, which I'm sure you're all familiar with. Also, what are language models? I'll introduce a little bit about how they work and how they fit in, and how does SNOMED play a role here. I'll talk about a little bit about, well, what foundations do they need? How do I get AI into my hospital or into my organizational system? And then I'll talk about some success stories that we have that I can share successfully that we've done with it in London. Great. So the universal problem, the electronic patient healthcare record, our entry into the healthcare system, or a copy of what's been going on with the patient. And so this is generally what it kind of looks like. It's there's a lot of free text, there's a lot of structured data fields where you can enter data. But the majority of clinically valuable information is held in the free text, right? And everything and everyone in a hospital generates data daily. And because it's in the free text, it's not easily analyzable. And so, we're talking about biomarkers, we're talking about what happened to the patient, why were they there as well. And doctors love to describe, especially if you're talking about mental health, there's a narrative to it as well. Sometimes when a patient visits a hospital, a diagnosis or a label cannot be directly given. And so a description or a narrative is much easier for a clinician to do. And so it's the most natural way of communicating. I'm talking to you in free text, right? Maybe one day I'll talk in emojis or equivalent of SNOMED codes. But until then, free text is the way to go, or unstructured narratives. But as we talk about, the size of the prize here, it's all trapped and it's all unlocked. And that's what we're all trying to do today, right? That's what all that SNOMED is trying to do, is trying to structure some of the clinically valuable information into something that we can reuse. Great. And reuse for secondary purposes. And what do I mean by secondary purposes? Hospital patient record systems are generally designed to treat patients, right? For a doctor to enter historical information and about what the patient came with and what they have, and to revisit it, right? To look at the patient's medical history, an important part of the diagnostic process. But it can be done data can be reused for much more than just direct patient care. Looking at how the current system or organization works by running quality improvement projects or audits. We spoke about research, or we heard today about research registries from cancer to dentistry. We heard about patient safety tools as well, adverse reactions, and how do we minimize that? And how do we essentially learn from mistakes of patients that have used the system, edit and improve it for the next patient coming in, so we don't make the same mistakes again. And so ultimately, data needs to be interoperable to share between organizations, sites, because that's the dream. Because the idea is, with bigger data, you might be able to uncover minute, unobvious trends. But ultimately, if you can structure it and organize it in a nice, succinct, clean manner, it enables organizations to easily be able to search and analyze their own data, right? So it empowers them to make data-informed decisions. So we were always talking about evidence-based medicine, value-based healthcare. How do we do that? Well, it comes from data. And so I spoke a little about the problems about unstructured text, and this era that we live in of this new AI landscape has really been popularized, has really come to the forefront of media, maybe not in the past few months, but has really been dominating the media of this idea of AI and larger language models. And I think OpenAI and ChatGPT really brought it to the mainstream public attention. But it's been going on for decades, actually, this field. And so generative AI is just, I guess, a type of artificial intelligence that sort of dazzles us with its ability to generate like data, images, text, resembling the data sets that it was trained on, right? And these large language models, the reason why it's sort of captured our imagination more than it has than other previous algorithms and releases is because it kind of reflects a little bit about ourselves, right? Like, I analyze, and I'm a data analyst in a hospital. And what do I do on a day-to-day basis, right? I summarize, I simplify, I organize, I analyze, compare, I write emails, and these large language models can seem like they do that, right? And so we can totally see a potential there. And I think that's what's captured the everyday public's attention. And so it's what if it can almost automate my job and replace it? And so this is why I guess we turn to this idea of large language models to help us structure this unstructured text. And so this field is called natural language processing, and it's just this area or field of how computers process and analyze free text or natural language. And so, if I took this sentence, the patient or they had a seizure in the morning, the computer has no idea what this means. And so how do they work? They first of all break this sentence or phrase into individual units, or specifically they're called tokens. And so these can be based on a word, which is done here, or it can be subwords, or it can be based on a character. And it often depends on whichever language that you're speaking on or speaking about. And this process is called tokenization. And so large language models, they're called large, right? And that's because they are built with vast scale of significant numbers of parameters and data. So parameters in be able to encapsulate the meanings of the words, and data for training. And so in this case, I want to understand what seizure means. And so what do? Is I pass it a massive data set, ask it to read it all. And with each example of how when seizure is mentioned, it learns a little bit more about it. And so if I gave you a word, right, Sagrada, what does it mean? Don't know. I mean, I made it up, right? So hopefully no one knows what that means. But if I said my Sagrada is white, maybe it's some sort of object. If I say, Anthony lives in a Sagrada, and then the Sagrada across the street has lots of windows, give it more and more examples, I get an idea, more and more of an idea about what this word means. Right, so maybe it means castle, a building, skyscraper, something with windows, etc. And so this is why you need huge amounts of data, or with some large language models, the entirety of the internet, right? And then through more examples, the deeper the understanding that one can get. And so what we end up with a hospital, analyzing all the data of free text in hospital, is that we end up with a huge set of words and context in which each and every word is mentioned in. And so we call that training. So we end up with a data set where words that are close together have a similar sort of meaning, right? And so it's all based on this assumption that similar words are used in a similar context, okay? And so if I said the patient collapsed, he had a seizure, the patient collapsed because they had a fit, they're interchangeable, so they have some sort of relationship, right? But if I said the diagnosis of epilepsy does not seizure, it doesn't quite work, right? And so the more examples, you can uncover the nuances in language. And so how the computer stores this information, it represents it, or these differences, mathematically. And this is through a vector, okay? And this is how machines understand language. And so this vector is adjusted based on the proximity of words that are close and other words that are distant. So it uses the context to uncover the meaning. And so just as you would describe a seizure by its characteristics, duration, type, etc., the value within the embedding quantifies the linguistic features, right? Because we're only talking about linguistic characteristics here because we're just studying language. And so this word embedding can consist of hundreds of values, right? And so they're usually 300, 768, depending on the types of models. So the more, or the larger this embedding space is, the more meaning it can capture in the word, right? But that means higher computational power as well. And so the way how it's set, we don't exactly know which parts of this mathematical embedding, what they mean, but we do know that relatively, it should be similar in its embedding space to other words of a similar meaning. And because they are now mathematically represented, we can, in this idea of if words appear in a similar context, then we can assume that they represent similar ideas or describe similar concepts. You can perform basic arithmetics on it as well. So in this example, I can do kidney failure minus kidney plus heart is equal to heart failure. And it captures it quite well, just from learning and reading from the data and representing language mathematically. And so this table represents various SNOMED codes that I've trained a model on in the hospital. And I've demonstrated that, here I pick a disease. In the first column is hypertension. Find me the SNOMED codes that in the free text that represent, and I filter by the semantic tag medication or drug types. And so it gives me a list of ones that correlate or most similar to it. And the same thing can go with other examples. So it can be quite clever, but remember that this is just through the use of language, right? There's no causation that can be inferred and just correlation. And so a key reason of how this is all possible is behind this architecture called the transformer. And so I'm not going to go into too much detail about it, but it's a deep learning architecture and it's a crucial building block. And the key part of this that has been a real big breakthrough is this idea or this concept of attention. And so previously how it worked is that this idea of, or this task of trying to predict or forecast, it was based on a sequential manner, where in order to predict the next word or to generate the next word, there was a variety of weighting done, where the previous word before it would be weighted more for the prediction. But we know that's not necessarily the case. Whereas attention, the transformer computes all words at the same time, allows for parallelization, and allows us to take advantage of these new architectures called GPUs. So it allows you to read all the text in a page at once. And so in this case, if I wanted to have a look at understand the word fit, right? In this case, the word fit, the meaning of the word can be derived from certain bits, and that's what attention does. And it allows you to focus on what is important to determine the meaning of the word fit. If I removed the variety of words that aren't highlighted here, like during the meeting, and I can still understand that this word fit in this context is referring to something seizure-like. Whereas in this case, the word fit, change of context, there's a different weight on different words. So here, software and system help determine the word fit, and distinguish and disambiguate it from the seizure terminology, just based on context, right? So attention is basically just helps the model focus on the parts of the context. And so now that we've tokenized, we've created mathematical embeddings, we have this intention, it's now machine understandable, right? And we can generate, and we can perform a whole variety of different tasks on it as well. And so this is all crucial to being able to generate sequence-to-sequence predictions. And we've all used ChatGPT, and that's basically how it works. Where in this case, you're trying to generate a sentence, and with each word it's generating, it has a list of candidate words or concepts based on the probability in which it's next mentioned. It doesn't just choose the highest probability of the next word. You can set it to choose the next variety of words. And so, based on its probability, and this, what I mean by that is, whenever you ask ChatGPT a question or a specific question, you're not going to always get the same response, right? And so this has been done by design, and so it doesn't just pick the highest probability; it predicts one from a certain span, right? And that is just called, and this parameter is called temperature as well. So some people may call it creativity. And so this is how large language models feel a little bit more natural as well. So it doesn't give you the same robotic answer every single time. So this idea of creativity is sometimes a downside if we're looking at it from an analytical point of view, right? I don't want it to be creative if I ask it, generate me the SNOMED code for epilepsy, right? I don't want it to be guessing a random number, right? Because that's what it does. It does that by design. And so this idea of generating text and generating answers based on whatever I chat to it, you can do that as well with one's health. And so consider each interaction with a health record that a patient comes in, the doctor writes. Essentially, that's a new chapter in a book of a patient. And so I can talk a little bit more, but a patient's history is essentially can be seen as a sequence of SNOMED CT concepts. And so in the same way, you can ask it to generate me a story about a unicorn that jumps over a tree or a river and that falls in love in the forest. You can say the same thing about the patient's medical history, right? We know in medicine, there are patterns to disease, right? Doctors call this experience. And so if I had something like diabetes, I have uncontrolled blood sugar level, I can have diabetic retinopathy, diabetic foot or complications, etc. as well. So we know that there are patterns and side effects of drugs, medications, etc. Great. And before we do, before I jump on the sort of use cases, I guess the foundations and tools in order for us to implement this form of AI is crucially important. And so I like to call this the hierarchy of needs of AI, right? And there's three core components. At the very base layer is really this data infrastructure and workflow that we need to essentially get right. And the majority of investment really should be in here. And the second one, I guess the crucial part of any form of AI is the data that it's trained on and has access to, right? And these are data lakes and being able to standardize information, etc. And then AI can be applied on top of that. And I use that AI as a very much umbrella term because it is really. And so this idea of focusing on the infrastructure in a hospital, you can have your actual EHR system. Sometimes you're integrating from outside sources. Sometimes you're looking at legacy data sources as well, right? Because you may not have had your EHR for your entire hospital's lifespan. You may have transitioned from previous EHR as well. And there are often, we heard earlier about siloed databases where data records are stored, but how do we bring them together? And so I'd like to separate them or segregate them based on different features. One being the structured data can be processed down one pipeline. And the other part is the unstructured, which uses your sort of information extraction and AI, where you can have and then form a data lake within an organization. And so a crucial part of this unstructured text is to extract and standardize the clinically valuable information. So we do this via SNOMED CT. And so in this case, with this random example, we have this AI model that can recognize and extract SNOMED CT codes. Not only does it recognize and extract SNOMED CT codes, what it does is labels what we call it meta tasks on it as well, right? Because it's not just having chest pain, it's a historical chest pain. It's not just night sweats, it's no night sweats as well. And it's crucially important, especially when you're doing forms of analytics. So this is already enormously powerful, structuring unstructured text. And so if we can structure and label unstructured text successfully and accurately, we can then use and take advantage of the structure of SNOMED CT to aggregate and to aggregate data based on the user's requirements. And so if I was to try and extract SNOMED CT codes based on the top level term epilepsy, I'm not just looking for the word epilepsy, right? I'm looking for acronyms, synonyms, JME, juvenile myoclonic epilepsy, other types of epilepsies as well. That's the actual question I'm asking. You know, if I'm asking it to extract the word extract if this patient has epilepsy, it's sometimes not always obvious, and sometimes I'm not just looking for the word epilepsy. But if I've got this model that can read it, it can understand. Obviously, with the caveat that all this form is just automation, right? If I had access to hundreds of analysts to do this manually, then I would, but unfortunately, I don't. Of course, because this is a form of automation and it is based on probabilities, we need to have some form of validation, especially when we're releasing this into production in a hospital, where in healthcare, a mistake can lead to critical errors. And so we have a whole validation pipeline where we not only validate models, but we have to validate the final data set that it results in as well. Maybe there's issues at point of entry, maybe it's some sort of processing, etc. And so we have a form of validation process where we try to integrate clinicians integrate or trick them into doing free labor for us. And we generally do this because all doctors and clinicians have to do audits. And we kind of say, hey, we can automate your audit for you, but you just need to validate our AI model. They're going to do this work anyway, so why don't we integrate them and have them label SNOMED codes for text to just train, to help train our models, right? Sometimes, most of the times, clinicians don't even know they're using SNOMED CT and they're validating it, right? They're just labeling whether this patient has epilepsy, they're labeling epilepsy with this label is the SNOMED code epilepsy. Great. So now we have an accurate model. We essentially set up a service within the hospital, and that is, we call it the data concierge, where we can surface and search through a hospital's record, and not just one hospital, several hospitals' records as well, where we standardize it across vendors, whether it's Epic, Cerner, Sunrise Allscripts, etc. Right? So we tend to cycle it between two areas, one being the structured data search and the other one being an unstructured, which is a bit more iterative, right? Because there could be mistakes, maybe there's different versions of SNOMED, maybe there's issues with SNOMED as well. And so we tend to call that complex query. But generally, we have unstructured data, turn it to structured, produce some form of analytics and insights and reports, and then we take action that we can feed back to the clinician, or the clinician takes action and can then either change how it's entered into the EHR in terms of structured, or changes medical practice or clinical practice back to the unstructured. And then once again, this iterative loop to continuously improve medical practice is what we try to strive towards. And so this is kind of how we structure data, not how we structure, but this is what it kind of looks like. We've got a database, and just to look at the clinical letters for outpatients, each row here just represents a single annotation or a SNOMED code, and we have 2.1 billion SNOMED annotations. This is just from one hospital, right? And so it's a huge amount of data to analyze and validate, but we are continuously striving to do that. Great. So data, structure, AI, so what, right? Ultimately, these are all tools to help us strive towards a specific a specific object, right? Ultimately, all these tools, we need to focus, we try to focus on the value to the clinician, the value to the patient, right? It's not about innovating at AI. It's not about, promoting SNOMED. At the end of the day, that's what we try to focus on. How do we improve services for our patients that we serve? So I want to talk to you a little bit about some success stories. The first one being, if you can structural data, means you can create dashboards of the entire hospital, dashboards where clinicians can access and surface and browse through those 2.1 billion SNOMED CT concepts, where they can enter SNOMED CT and readily pre-built tabular graphs and figures are produced. We can summarize and have a look at hospitals. We can have a look at health trends, right? Population health research. We can understand, well, what is the most prevalent diseases and symptoms, all based on the trapped free text. We can have a look at, we can break it down based on, well, which level of the SNOMED hierarchy are we interested in? Are we interested based on the top level, the semantic tags? Are we interested in epilepsy, or are we interested in certain types of juvenile types of epilepsy, for example? And you can do that with any other areas of SNOMED CT as well. Another, or a major success story of having an AI model that can read text is recently we just transitioned to a new EHR system. We acquired an EHR system, and then we realized, hey, it's empty, right? There's nothing in this EHR system. What happened to all the historical data? Well, the old system is all in free text. Some hospitals choose to employ, hundreds of doctors to extract it and label it and code it into SNOMED CT, into the problem list. But hey, we thought, why not have a semi-automated approach where we have an AI read it and add it to the EHR, and clinicians, when they see their next patient, they just ask them. They ask them and they essentially validate it. So we've incorporated AI into their current workflows to validate these lists. And so we've saved the trust huge amounts of money, and analysts as well, huge amounts of time to be able to do this. Obviously, that was historical, right? What about live? Based on our system in Epic, as a clinician writes their free text, we let clinicians be clinicians. They may not know anything about SNOMED, but that's fine. This AI, or this tool that we made called MyAid, it analyzes and extracts and then prompts the clinician to tick which SNOMED codes they should use for this patient. And this is quite successful, right? Because they don't care if it's SNOMED or any other terminology. It's just a word popping up, right? It says epilepsy disorder. Sorry, forgive me about using epilepsy as a example all the time. I can change it, but yeah, it's just an example here. And so what it allows you to do, or allows the clinician to do, or this whole workflow, is to hide the complexity of SNOMED away from the clinician. It allows them to just enter things naturally, whether it's in free text, whether they dictate certain words or the patient episode. And it allows them to essentially focus on being doctors rather than scrolling through, figuring out and clicking which SNOMED code from the 300,000 SNOMED codes are most relevant. Sometimes it's not just diseases as well. A really crucial key part of analyzing data is privacy. And it's in the same way how we can extract and pull out clinically valuable information, we can also hide various record artifacts. And in this case, this is anonymizing or de-identifying the free text to protect patients' right to privacy. And so in this case, I generated a synthetic patient letter about a patient called Alzheimer's. And it just happens that this patient called Alzheimer's has Alzheimer's disease as well. And so based on this contextual extraction, you can retain and leave out Alzheimer's, the name, but it can redact the name, but then retain the disease it's all mentioned. Not only can it redact it, it can also replace it with the tag or the semantic tag or the record artifact or the observable entity that it's based on. And so this is quite important because it can retain the context, right? Whether it's the name, Anthony had epilepsy, or maybe it's my sister had epilepsy as well. That context is crucially important for deriving text. And it just happens that a lot of diseases just quite frustratingly are named after people. A lot of brand names for drugs are named after everyday words. Sometimes it's called today, right? That can be a brand name, which can be incredibly frustrating to extract from free text. Great. Other areas is for research, right? How do we improve how we manage patients in the healthcare system? Can we use natural language? In this case, this example is looking at epilepsy. And it is looking for various predictors of those patients who do not respond well to medication. Are there areas in their history which may not be obvious from a single patient's perspective? But from looking at big data, can we look at it? Right? We've got access. We have centralized all the data. We've got a tool that can read through all their patient historical notes across the past couple of decades. We can identify, well, what happened and what went wrong. Sometimes this figure demonstrates at the point of entry, looking at first seizure. At A&E, there's a lot of suspected first seizures, or the reason why they're referred to this first seizure clinic. And sort of the left-hand side in this diagram, we can eventually trace the patient's health trajectory into what their eventual final diagnosis is, right? It's just a visual diagram. And so what we realize is like, hey, a lot of patients that are being referred to the first seizure clinic don't actually, only a third of them actually develop epilepsy. A third have a single episode, and a third actually have some sort of cardiovascular event, usually a cardiac syncope, right? And so what happens, and by analyzing this data and looking at patient pathways, we find that patients bounce around. The neurologist refers the patient to the cardiologist refers the patient back to the neurologist. But actually, we know that from this first seizure event, nearly a third is either cardiovascular or neurological. Why not have that clinic on the same day? Saves the patient time, saves the doctor's time, and ultimately, it's not just saves them time in getting to that diagnosis. A timely diagnosis has major implications of downstream events as well, right? For diagnostic tests, etc. And so it allows you to analyze when did they have their MRI, when did they have their EEG as well, and how do you adjust this patient pathway to change the management of the patient? Because sometimes with a lot of these uncurable diseases, the management of a patient can go a long way. We heard about cancer and cancer registries as well. That's a very big area. I'd use this example of head and neck cancer. I guess we didn't have a registry for any form of research for multi-site collaboration. Well, we can look into it and we can extract valuable key bits of information to then join in whichever structure, whichever format other research groups need as well. In this case, the previous talk talked about medical billing. It's something else. We obviously, by extracting SNOMED CT codes accurately from free text, we can also use the inbuilt mapping to ICD-10, which is then sent to billing codes as well. And so this is something that was, I guess, there's a lot of emphasis. It's an administrative use case, which can be enormously valuable financially for the trust or for a hospital. And so in this case, looking at after the deficit after COVID-19 and being almost overwhelmed by the number of patients coming in, we had to deal with the backlog. But great, AI can read through thousands of records. I mean, in our case, about 50,000 records per hour, and attach it with an accurate code. The actual time limiting step is having it validated to make sure we're attaching a correct code. But in this case, the risk is much lower. Right, you attach an incorrect cost code, it's not as bad as attaching a wrong diagnosis, which is going to affect the life of a patient as well. But of course, the government, or in this case, they're our customer in that sense to provide us with financial remuneration for the services that we provide. They want it to be as accurate as possible. So we do various audits, and that's what clinical coders do, and they review the accuracy and performance of these models. And so in this case, recently we just generated an additional £5.5 million for procedure forms, but also for inpatient coding. Mandatory comorbidities is something that is just simply not done. And that's another couple million that we generated as well, based for medical billing. Patients at risk, right? Patient safety. In this case, there was a product recall, a defect in one of the patient masks. In one of the sleep masks that were used. We realized there wasn't any registry which had a record of all the patients that had been given this certain product. Right? We almost had to go through the free text to understand, well, which patients had a sleep mask prescribed to them. And then to follow up with their clinicians to have a conversation, return them and issue with them a new one. That is now possible. Not just this patient safety about if it's now possible or not, of course, going retrospective, it's a bit easier, but also prospectively as well. In this case, there's certain medications that are known to have serious side effects. In this case, in this example, is methotrexate, right? And it's a medication that's associated with some severe side effects, such as liver failure. And so any signs, despite they get prescribed, they maybe go away for 4 or 5 weeks or maybe months, and they come back to A&E with liver issues. That patient can be flagged to their overseeing physician that they are on this medication, and so it's not missed. And so you can catch it earlier, and their physician can take them and stop their medication as well. I guess I can count a number of examples of success stories in this example with patient safety. Sodium valproate, going back to my epilepsy example, sodium valproate was associated with birth defects in women with of childbearing age. And so there was national guidelines or research that came out that was associated. Wait, hang on a minute. We don't have a list of patients on that medication. How do we do that, right? It's taking advantage of that data, being able to reuse it. In this case for direct patient care, but to be able to analyze it, surface that data as well in a timely impact to be able to, in a way, directly help patients' lives as an analyst, right? Not even as a physician, it's by using data to support the frontline staff. I guess another example of a success story. So I'm going through so many, but I promise you this is the last one. And it's identifying members of armed forces. Quite a really proud one in our hospital, where we treasure our armed forces, and sometimes it's not just the UK armed forces members. It's Gurkhas and members of satellite communities as well, who just happen to be in London and enter the hospital. So they're eligible for a variety of benefits and services. However, most veterans are not aware of the benefits that they're entitled to. And so we have a team that forms part of this Armed Forces Covenant, and they are tasked with trying to flesh out and find these patients to inform them that, hey, you're entitled to these certain benefits. It's up to you to choose which ones you can choose to use or not, but it's there if you need it. But wait, once again, they have no idea which patients are veterans and which ones are not. Currently, there's a whole team reading every single, or trying to read every single record. Is this patient a veteran or not? Is this patient associated with a veteran or not? Or are they actively serving, etc. But instead, we can look for certain terms in the text using SNOMED CT, military, army, navy, etc., to be able to readily, quickly identify them, to then give to the analyst, to then go through and then contact these patients, right? Basically, a recruitment exercise as well, like a clinical trial. Great. So just going back to this idea of generative AI in healthcare. And that is, once again, just recapping, to generate new sequences and the next word or the next token. So because now we've got free text, we've structured it, each patient has a number of historical data. We can sequentially order them based on each interaction they've had with the healthcare system. A story, as I said, a story of one's health. And so this is where we built a tool called Foresight, where we can train based on the millions of stories that the hospital has written about these people. And then we can input these tasks of a new patient coming in, and we can then forecast you can forecast the rest of their timeline, forecast the rest of their trajectory, right? What does the rest of their story to say about them, or about their health more specifically? And then, of course, using SNOMED CT, it allows you to filter based on the various semantic tags and types. Which diseases are likely to come? Which types of side effects are likely to come? Which kind of medications as well are relevant for this patient? And based on that as well, what kind of side effects they may encounter? And so we built this platform, and it's something that's tended to be used. We validated it in a variety of hospitals, and we learned that in the same way of reading feeding at which kind of data source, AI is great at analyzing and picking up patterns, right? In the same way, depending on the hospital, each hospital has a different, or in this case, there's different specialism. It reflects the types of patients that each hospital sees. So a mental health hospital, by default, it would generally tend to focus towards mental health disorders. And so its performance actually is quite good, right? I mean, we're talking about 60 to 70%, trying to predict the next SNOMED code that will be entered in their medical history, right? But it's not just, I mean, if I gave the task to any doctor, which patient will come next and which SNOMED code will they generate, 60% will be very ambitious there to give you the least. But then when you give it a list of 10 SNOMED codes, it's likely to be in one of these 10. The accuracy goes up quite high as well. And so this is something that's being explored quite actively, especially by the research community, because there's a variety of applications, right? Clinical risk prediction, insurance, forecasting cost as well, diagnostic suggestions as well. But something that we're quite interested in is looking at this idea of digital twins or trial emulation, where you can give a patient you can enter a patient's history and timeline, and you can digitally intervene. Well, what happens to this health story if they take drug X rather than drug Y? What side effects are they likely to generate or not, right? And so, of course, there are a number of limitations and side effects, and I mean, not side effects, but limitations and things that you don't want to implement into clinical practice, but still something to think about trends that could be surfaced here, which is quite exciting. So I'm going to round up there. Thank you very much for being so patient and staying to the end. And yeah, looking forward to any questions, and I'll be around for the rest of this afternoon if you want to have a chat. So thank you very much.
So thank you very much, Anthony. This is very great and very so interesting also that it make you think about a lot of things. I just want to know if the three of you can just come up and then we can maybe do some questions together as the last thing before we kind of give you out to the Norwegian spring here. So first of all, I mean, maybe we should start with you, since we had the last speaker, Anthony. I think it was very, very interesting, as I said. Of course, I mean, all the things happening with AI made us thinking about, you know, what is the biggest threat, of course, going into health. When you think about health and health records, what do you think is the biggest threats?
I guess.
Do you want to sit, stand, talk there? Yes.
Sorry, I guess the biggest risk of AI is, I guess, incorrect reliance upon the output, right? It is, I mean, it's nice that it's not so great, and so we often question it, but I often find the biggest problem is when it starts working well, and then we start relying on it, and then we don't question it. And so that's often when the risk comes, and especially when consequences are high. And understanding when is accurate or how accurate is accurate enough can be a very hard thing to determine. You know, in some cases, 70% is good enough. Sometimes 99.9% is not good enough. And so this cost of, I guess, impact to the patient is something to always keep in mind.
Very interesting, yeah. So there's many things, probably a lot of other questions that we can open on the floor a little bit more later. So to Sylvia, I'm wondering a little bit, how can, because you talked a little bit about the side event that's been now thinking about in the WHA meetings that's coming up in May, and that Netherlands is hosting a side event. Is there anything that, if we are interested to support this side event, what would you think that Norway should do, or do you have any?
Well, for me, it's looking into the room and looking for the answer.
Oh, that's too.
Because Herco will know.
That's Herco. Do you want to say something?
Yes, sure. So the side event will be held at the World Health Assembly on May 19th, which is the first day of the meetings in Geneva. And we would ask for Norway to send their delegation to this meeting so that we can enforce and reinforce the importance of digital health for the WHO, that they keep investing in it, because the WHO is now reviewing all of their budgets and their priorities and where they put their resources. So I think that's one thing that they can do. But Norway is already part of the collaboration between the WHO and SNOMED as a member country, or as from the country need. So invite other countries to join that collaboration from not their SNOMED need, nor just their ICD need, but for the need for these to work together and solve this interoperability problem.
Thank you very much. That's interesting for us to know, I guess. So thank you. So, and then about maybe Licínio, about the EHDS, you said about a lot of things that's going on that it was very also interesting to think. What do you think? I mean, what kind of else? We'll start with that. What kind of obstacles do you see when it comes to implement the things going on in the EHDS? Do you have any comments on that?
On the roadmap, on the challenges.
On the roadmaps and the challenges, yeah. Do you want to talk here?
I think.
Oh, you have, yeah, right. Okay.
So there are, whenever we are working on the ground with hospitals and healthcare facilities, there is always the word legacy. There is a lot of legacy data. There are a lot of legacy systems. And in order to have a vision like the one that the EHDS has, it has a timeline, it has a vision, but it requires courage and requires investment And the type of investment, what we see all around Europe is that our health systems are constrained by budget limitations. So for me, whenever I speak with you, is always a dimension to say, how are you foreseeing the change management it's needed, and how will you finance the change? And when I don't see that concern, we will do it, but how will you finance the change? I'm starting to see that this is the weakest point on let's say, on the roadmap ahead. We don't speak about will we invest so that the full health system adapts to the requirements of the European health data space. So at SNOMED International, we are trying to make sure that the terminology and the tools and the services support the countries in going in that direction. So we are trying to make the quality improvements in terminology, so to remove the issues that some people may find. We are trying to provide as many tools as open source and as many services as we can, so that burden, the financial burden, is not so high. So that's how we contribute with our managed services, with our implementation support teams, education when we provide the courses. So, and even our close contact with the NRCs to provide consultancy, how to face these challenges, is a way for us to contribute to minimize this burden, at least in some way.
Okay, thank you very much. Very interesting. So, and then maybe for Stefanie, because I mean, seeing your journey with the code system, the terminology together, and then thinking about it, it looks very much about what we call the standardized language in our visions, like 5-6 years ago. And I was wondering, how important do you think it is to do mandatory works, and what are you actually, you might have been saying some of it in your talk, but would you like to elaborate a little bit on that?
Yeah, thank you very much for the question. For us, the mandatory part, we would hope that we could avoid it, but learning from other countries, we're a little bit behind, for example, towards Netherlands or with the SNOMED implementation to other countries. So we think that at some point there is direction needed. So it's probably the word mandatory, I think, is a little bit too strong, but direction. And for that, we want to use the terminology server as well. We're working with our digitalization agency, who is giving standards in kind of the interfaces between systems and how interoperable EHR systems need to be. So they're setting standards, and we try to work with them and include the semantic requirements in that. So whenever a standard is set, we try to investigate, is it possible to use such a common approach on the code systems underneath? Or is there legacy that we need to cater off and that we need a certain amount of time for a switch? How do we address this with the historical data that we need to have in a patient summary or in a patient journey? So there's all these aspects that we try to address together with all the players in the field. And for us, it's very important. We don't have a central IT system. So for us in Germany, manufacturers are free on the market to provide what they would like to provide. So it's very important for us to work with them and see what they can do, in which time frame, and how to implement it. Still, I do think that a certain push from government or from the organizations that are driving the digitalization is necessary. And the EHDS anyway gives this push. So even though if we would try to avoid it, the EHDS brings it. And so we try to align with that a lot as well. So we're not alone in Germany. We're thinking EU and plus world. So we need to think, not inventing something for Germany now, and then 3 years later have to throw everything overboard and go back again and start all over.
So maybe a supplementary question that you may not be able to answer, but I wonder, is there an obstacle if the EU members cannot or will not be able to implement the EHDS standards? How would that be a problem for Europe?
So I think the EHDS really addresses a couple of layers. So it addresses the layer of the cross-border data exchange, which already is in place in some European settings between some countries. And it's kind of a voluntary structure right now to board on. where you have the possibility from your local system to map to the international kind of the system that you need for cross-border. So mapping is already a possibility to be used. And I guess for a transformation period, that will definitely be the place in the EHDS. So even though people will not switch immediately, the timeline that Licínio presented is quite ambitious, 4 years, even though it seems long, is for code systems change, I think, a very short period. So there will be transition periods on that. But in the long run, the full benefit from what we want to have in Germany from the EHDS, especially on secondary data, like what you showed in a few examples, is only possible if Europe pools the data in a kind of standardized way, because you are working just with English language. But if you go to Europe, you have so many languages, and then AI might have to train differently and much more complicated. So for that, I think the standardization would be even a benefit more. And that would, in the end, benefit our patients in Germany.
So much wisdom's coming here. So I can open now to the floor if there's any more questions. Do anybody have some?
I have one online, so maybe
Yep.
we can do that one first, and then we can go to the
Go ahead.
room. So it's from Kingling Wallen in Sweden. So she said, "Thank you, Anthony, for your presentation. I wonder if you have tested your model on primary care data to assessment symptoms and see if these models can predict which patients are at risk for developing cancer or have low-grade cancer that has not been detected, something similar to the work of Dr. William Hamilton."
Yeah, brilliant. Well, thanks for that question. So I'm not too familiar with the work of Dr. William Hamilton, but it can certainly be applied to primary care data. In the UK, primary care data is predominantly structured, and it's structured in nature. I do have a team that is currently working and exploring that on primary care data to forecast predictions and what disease will happen next. But in terms of, and so you can avoid that whole complexity of extracting that data first to SNOMED CT codes or standardized terms. And that's because in primary care, it's all already, in the UK anyway, it's all entered in SNOMED CT. So that level of complexity has disappeared. But yeah, from that, I haven't personally done it, but we have a team that's looking at it and will, share results in a few months, hopefully. And so, yeah, keep an eye out on the space. Thanks.
Great. Go ahead, please.
I've got another topic for an AI question for Anthony. Obviously, LLMs are such a hot topic at the moment, and we're all drawn to new technology, sometimes blindly. I think a lot of your work is based on NLP processes, which is a slightly older technology. But I wonder if you could compare and contrast, the deployment of LLM technology, which is often hosted online, versus NLP, maybe in terms of cost, scalability, privacy. I'd be interested to hear your thoughts.
Yeah, fantastic. So just to clarify, I guess, a little bit of that question. So NLP is the broader field of how computers can understand free text or natural language, and LLMs or these large language models or language models can, I guess, is a small part of it. I mean, well, it's recently big in terms of headlines, but actually this rule-based regexes, and we use NLP on a day-to-day basis. I mean, day-to-day, as in if you're in front of a computer and you're in a large document or a web page and you need to find a word, you could do a Control F and you look and you search for the word epilepsy, and then it surfaces or highlights that word, right? There's a whole algorithm or series of algorithms that are optimized to do that, right? We don't even think about it, right? But they are. We never question if it's right or wrong, but that is a form of NLP as well. So yeah, recently this LLM side or this sort of machine learning, you're not writing any explicit rules. You're just showing it examples, right? Almost like figure out all the different synonyms and terms that seizure can be mentioned in, right? Based on its context. And this is where it's a lot of hype because medical language in a hospital is quite complex. It has a lot of jargon. It has jargon and very much domain expertise, which sometimes an analyst just simply does not have that, same knowledge as a medical doctor. So it's unfair to, expect them to do it in that way. So just really quickly to answer your question in terms of the advantage, disadvantages, LLMs, they're big, huge amounts of compute, huge amounts of data training, which may not always be feasible. And so it's not always, or should not always be the first choice to jump to. You should not necessarily be training or retraining data, which can cost millions, on every single time SNOMED is released, whenever there's a new extension, whenever there's a new release as well. So sometimes taking pre-existing models to use it, great, but even sometimes to host those models is already computationally expensive. So there's a trade-off between accuracy. LLMs bigger can generally perform a little bit more accurately if trained well, but it comes at a cost of computational expense and sometimes validation and training as well. So hopefully that answers your question in terms of what are the ups and downs. Thanks.
Thank you very much, Anthony. So there's one more question. Yeah.
So I've got a question for the government agents from the Netherlands and Germany. And my question is, how far are your two governments away from accepting AI-derived HRGs and DRGs for billing purposes?
Your question, to clarify, for billing purposes, you said, right? I think that's a far way to go. So that's a short answer, but I think the first step is maybe looking into other ways to use our data towards billing. But what I think Stefanie also said or highlighted on is you want to be 100% sure that it's correct. And that's also what Anthony mentioned. So I'm not even sure if I would advise it at the moment to do so.
Maybe add to this. So I would agree. We would not do full AI on billing. So free text AI billing would probably not be accepted any time soon. But we do see very big potential in free text AI coding, controlling the coding, and then going to billing. So what you showed in the examples of the automated annotation of the text, that's really something where we hope that our IT industry will pick up on that and allow the users to not spend too much time on the coding itself. So ideally, the user would never see if he uses SNOMED, ICD, whatever in the background, but rather see, this is my text. And then in the end, the billing and whatever would be catered to with controlling in the hospital, checking this or something. So it's not, we don't see the coding at the point of care. And that's where we think AI would be a big revolution in the application.
Okay.
Go ahead, please, Jan-André.
Thank you. And thank you all for a very interesting afternoon. I'm not sure who this question is for, but it's well, throw it out there because some of you are talking about we can't go AI for billing because we need to be 100% sure. And Anthony was measuring some use cases are 70%, sometimes you need to be 99.9%. How do you see AI or computerized interpretation in relation to manual interpretation? Are you actually sure that the billing done by people or are they 99.9%? So how would you say today's technical environment matches up to the human-driven environment?
Maybe I can start and then you can go as well. So for us, the example is the in-care coding, in hospital coding and the outpatient coding. Hospital coding underlies clear rules. There's controlling mechanisms. There's an authority going in controlling the data. Quality of data is very good according to the billing purpose. Outpatient, the coding itself is not so much driving the billing. There is no control or little control. Data differs. So it really applies to the use case, I think. But from the outpatient coding, we can see that if there's no big emphasis on it, there's a whole variety on. So I agree, manual coding is not of high quality as well. So here again, I would see the help of the AI as being a big benefit to data quality as well. in providing the person who has then to sign off on the codes with a very small selection instead of a whole code system to pick from.
Yeah, so I can completely agree with that. And just to add to that point, even now, I guess to say that we do AI and try to automate clinical coding is still quite controversial, even in the hospitals that we work at. And we still have a clinical coding department. We still have real humans working and validating the codes and still doing their absolute job. It's just that their roles are going to change from doing everything manually, from being behind, from being stressed, from having to work in a, very much one-off manner, right? So rather than coding manually, tossing that work away, doing the net set of code, they are building training data sets, right? And so this transition to an autonomous or auto coder, exists in steps, right? And so even now, the performance is, I'm going to controversially say this, is a little bit better than it manually, at least for our coders in our hospitals. But we can't really say that because maybe our coders are quite poor performance, right? Maybe the coders are better elsewhere. Even though we've validated and checked at other hospitals too, still doesn't matter. Maybe London coders are not that great, right? But I think in realistic measures, it's not that they're not great. There are time pressures that humans face. They've got families to go to. They can't work 24 hours, even though we want them to and we need them to. AI can, right? They don't go on strike, etc. And so this idea of it will transition in phases, right? We have to build trust. We have to build engagement, both with doctors, with administrative staff, with researchers. And that's why it'll be a gradual process and it won't happen overnight. Yeah, thanks.
Great. Thank you very much for a good answer also. So I can see that now, time passes quickly when you have fun. So this is what happens. And we are now beginning to go to an end. So I just want to give a small appreciating little gift from the health director, Norwegian Director of Health. And then for all of you. So thank you very much, all for you, and then also to the rest of you, because it's been a very interesting day for us. So when we were asked if maybe you want to have a Norwegian day, because we want to make SNOMED business meeting, as we call it, to come to Norway, we thought maybe, it's going to be that's just going to be very interesting and very fast way to do a new program. But we understand it takes a lot to make these conferences. So now I understand that we have been working to get this done. So I'm very proud. And that's why I want to thank a couple of people here. So just to make clear to the Norwegian audience that's here, a lot of people who doesn't know so much about SNOMED International. So I just want to say that it's a member-based organization with around 50 countries, and it's one country, one vote. So that means something, And then also, we are in the Norwegian Directorate of Health. We are a member. We are holding a membership for the rest of Norway. So that's what it is. And then in this community, we have release centers, and the Norway Release Center is also there in the Director of Health. And so we have also handling a lot of questions and anything in this release center. So now I'd like to get two people to stand up, and that's Trine and Beate Christensen. I think there's Beate. Where's Trine? So the two of them are representing the Norwegian NRC, and Beate is head of the terminology department in the Health Directorate, and they're doing a marvelous job. I just wanted all of you to see that these are the two people. And then also, I would like to say, there's a lot of teams going on there. So also, I would like the rest of the teams in the terminology teams, can you just stand up? Please, come on. Hi, great. Thank you very much. I know you want to be anonymous, but you know. So that's thank you to everybody. And then I need to have the 4 people who's actually been making this to happen. So, because there's one project manager, and that's Marta. Can you please stand up? Then we have Anne, and then we have Ole, and also we have Jan Ivar. Yeah, I think you can come up to the stage show, so you can just say thank you. So I just wanted to congratulate you for a very good, nice conference, and that was it that I wanted to do. So please take your our sincere gratulation for doing this conference so good. So, and then thank you to all. That's what I want to say. So right now it's we just come to an end, and we want to thank you very much for being a part of this Norwegian Day and to make this a memorable thing. And we have learned so much. We feel like this is now coming to an end, but it's not coming to an end for what we do in terminology department in Director of Health, and also with SNOMED International backing us up with a lot of things. I think that we have a lot of interesting days to come about these things.